Yeah. Xo'sh, texnik muammolarni yechdik. Boshlaymiz. Bugungi spikerimiz Facebookda 9 yildan beri ishlayotgan va yiliga 400 ta Facebook intervyu o'tkazadigan. Shu Facebook ish kitobchasi nima shu bo'ladi? Facebook intervyuni. Yiliga 400 ta intervyu oladigan va O'zbekistonga hech qanaqa plansiz, hech kimni taklifi bilan emas, hech kim hech qanaqa o'rtog'isiz kelib qolib, prosta Google'ga developer group deb yozganda jiddiy chiqib qolgan. Shunaqa tanishib qoldik bu odam bilan. Bu communityning yaxshi tomoni. Bugungi naqada Facebookga intervyuga kirish, to есть Facebook intervyusi haqida o'zini o'qitdi va intervyudan o'tish va intervyu olish bilan o'rtoqlashadi. Ota Murtadha, o'zbekchasiga Murtadha bo'ladi. Yeah.
All right. Let's do this. Hey guys, how's it going? All right. This is so great. So I used to do these meetups every week, maybe, or every 2 weeks. I was in a different country or a different city doing a meetup, and for the last 2 years or 1 year and a half, I have not done a single one because of COVID. We've not been able to travel or gather. And now with Uzbekistan, I'm back here doing the first time again since 2 years almost. So it's really nice. So it's really exciting to be with you guys. Can everybody hear me okay? People in the back, hear me okay? And everybody's okay with English? Yes? Yeah? All right, perfect. So this is a huge turnout. I'm so excited to be here with you and to share a little bit about myself and also hear from you. Before I start talking about me, I want to hear about you. So raise your hand if you're a university student. Wow, okay, most people are students. Raise your hand if you are going to graduate in the next 6 months. Okay, few people. Raise your hands if you're already graduated and you're working or looking for a job. Okay, all right. This is great. So we have about 1/3 of people who are done school and about 2/3 or a little more maybe of students. So this is great. Today we're going to be talking about coding interviews and job interviews in the tech industry. So this will be interesting and relevant to all of you because most of you are students, and even if you're not a student, you know, you might be looking for a job, whether even if you have one or not. So talking about tech interviews is very important. And in today's talk, I will be sharing mostly about my experience as an engineer at Facebook. I've been at Facebook for nearly 8 years now, and I've interviewed hundreds of people throughout my time there. So I'll talk to you about how I interview people, what do I look for, what do I think about when I'm interviewing them. So stay tuned. You know, it's gonna be exciting. Now, a little bit about me is this is my name, this is my contact information. I'm Murtadha, or in local Uzbek, probably call me Murtaza. Yeah, it's more the local way of saying it. Originally, I'm from Iraq, from Baghdad, and I grew up in Iraq most of my life, and I studied computer engineering at university. And while I was a student in university, I was applying for jobs and internships. I did a few internships in small companies, startups, and then in my 4th year of university, I did an internship with Facebook. And at the end of the internship, they said, "Hey, we like you. We want you to come back and work with us full time." So I've been at Facebook since then, since 2013. So that's really my story. And the project I work on is called Internet. It used to be called Internet.org. Now it's called Facebook Connectivity, which has the purpose of bringing internet to places in the world that are not yet connected or that are poorly connected. So we're working on providing connectivity everywhere, and where we believe internet is an important part of everybody's needs. So it's like you need electricity and water and power, education, and internet is one of those important needs in today's world. So we're working on that, and we have a lot of work to do. This is my contact information. I'd love to stay in touch with you guys. If you post anything from today's session, or if you go home and you have questions, please write to me. Or if you later get a job, and after what we talk about today, I would love to hear that story. It inspires me to hear about what you're doing and how today's session helped you, or maybe it didn't help you. Tell me that too, if you thought it was not helpful. I want to hear from you, so please stay in touch with me. If you use Facebook, or recently using Instagram, but I know that's already too old now. I need to use TikTok, so I don't have a TikTok yet, but I'm working on it. Okay, let's get started. So, yeah, it's great. It's working. So, today's talk it's for you. I want you to be participating with me, engaged. Don't be shy. Ask me questions. If there's anything I say that's unclear, please just interrupt me. And I want us to have a conversation and not just me standing here talking all day. So please participate with me. Raise your hand if I don't see you, or just start talking if you need. So let's get started and talk about the interview process. How do I prepare for the interview process? You're here to think about that. So we think about this in 3 parts. It's important to understand the process itself, like what are the steps of the interview. Also, it's important to understand the material, like what are the things we ask or focus on during the interview. And finally, important to know how to communicate. So communication is actually a big part of it. Maybe more than 1/3 of the success in the interview comes from communication. And I interview a lot of people. They seem like they're very talented, very smart. They know a lot of things. They can solve problems, but they have weak communication, and that's a problem. And if your communication is weak, it could be a reason for not passing the interview. So very important to focus on that. We'll talk a little bit more about that in the next few slides. But most importantly, underneath all of this, how do you get better at understanding the process or getting familiar with the material or communicating? The way you get better at it is by practicing. Practice, practice, practice. Practice with your friends, practice with your little brother, practice with your dad or your mom, so anybody. You can sit and, hey, let me solve an interview problem with you. This will be a good thing to do all the time. Practice, practice. If you can't find anybody, practice with yourself. But having somebody to practice with is really important too. Even if they don't know what you're doing, even if they don't understand coding, just having someone in the room gives you that feeling of the interview with somebody, and there's that pressure. Obviously, it's good if it's somebody who understands you and can understand what you're writing. But if you can't find that, it's okay too. Okay. So let's talk about the steps of the getting an offer, right? Everybody, why do we do a job interview? Because we want to get a job offer. And how do you get a job offer? So there are different steps. One is writing a resume and making sure your resume is great. After you have a good resume, you go on and try to get an interview. We'll talk about that. And then you do well in the interview, and then we'll share some tips about what happens after the interview and what you do. So let's get into it. The resume. Why do we care about resumes, and what is the goal of it? Really, the goal is to tell your story. So we want to hear about your past experiences, things you've done in the past, and the impact you had on the projects or the teams you've worked on. So make sure you talk about your individual contributions and the impact you've done. Not just what the project did or what the team did, but you individually. What did you do? Making sure that you show what you're passionate about. So if you're passionate about artificial intelligence, if you're passionate about virtual reality, communicating that in the resume through the projects and the activities you've done is also important. Make sure you highlight your accomplishments, but also be genuine about it. Don't exaggerate or say things that are not true, because you will be discussing your resume with somebody. So if you say things that are not real, it'll be obvious and it'll be awkward when you talk about it. Okay, so things to include on the resume, just some basic information about you, which university you attended, if you attended university, or if you've taken any certifications or courses, if you are graduating, when do you expect to graduate, or if you already did, when did you graduate? Include your GPA too, if you can, if you have information about your grades. And then the most significant part of your resume will be the projects that you worked on. So this will be really the thing that shows your story, your passion, your accomplishments through the project section, which will probably be more like 3/4 of your resume talking about project. So when you talk about projects, talk about any industry experience you've had, internships, jobs, startups, any interesting classes that you've taken or personal projects. So now when you talk about this with interesting classes, don't mention the class that you took that is introduction to programming, right? Like that's not interesting. Talk about things that are more advanced or more relevant. If you're applying for a job that requires experience in artificial intelligence, maybe you took a course on artificial intelligence in college. You can include that. Also, when you talk about class projects, some people say, hey, I don't have any industry experience. I have never had a job before. What do I include? It's okay to include your class projects, but the ones also that are interesting, that had a challenge, that were something meaningful. Not your hello world that you did, when you started learning how to code. That's not very interesting. So just think about something. And if none of your classes were interesting, none of your homework was interesting, and none of your classroom projects were interesting, then just go and find a project outside of the classroom and do it. This is something, when I was a student, one of the projects on my resume was, I was playing this little video game. It was a puzzle on my phone, and you just move things around, you move in blocks, and you're trying to get one block to the other side of the screen, and there are things blocking you and stuff like that. So it's like a little bit of a visual puzzle, or there's maybe a little bit of logic, or I don't know, something in it. But anyways, I was trying to solve it, and I solved a few levels, and then I got to a level where I couldn't solve it anymore. And so I just thought, well, maybe I can write a program, or I can write an algorithm that solves this puzzle. So I just started looking it up, and I went, at the time I was learning C++, so I went and researched a bunch of things, how to represent a board game in the computer using a hashing method that lets you represent the state of the game and each move and so on. And it was like, learning how algorithms solve chess or play chess between like a computer and a human, and learning some of those techniques to use them in my little program. And I just ended up learning a whole bunch. In the end, I solved the puzzle by the program. It took me maybe like 3 or 4 weeks of researching and coding, and maybe it was not a very useful application to build. Like nobody used it. It doesn't make the world a better place, but I learned from it, and I put this on my resume. And this is an example of where I didn't have an opportunity to do this in a class, or it was not a project that I did in a job, but I just made it up. And then I, put it on my resume, and it shows, hey, I'm interested in coding beyond just the immediate things that I have to do for the class or the job. So think about those opportunities too. And also include links where it's applicable. If you have any GitHub or blogs that you contribute to, including them on your resume is good. And like I said earlier, like any relevant coursework, if you took an AI or VR or something that is a little bit interesting, and advanced, then including those could also be helpful on the resume. Okay, let's move on and talk about how to get an interview. So there are different ways to do that. One is getting a referral from current employees. A lot of companies have a system where existing employees can refer people they know to the job. The idea is like, if you're a good engineer, a good programmer, probably you know other people who are too. So refer those people. We want to hire them. So if you know someone who works in a company that can refer you, say, hey, can you refer me? I can refer people to Facebook, and usually that is a good step to help them get the interview. After the referral, you still have to do well in the interview. it does give you an advantage in the interview. It only helps you get the interview. So you still have to have the skills and the training to pass the interview. Other ways is to attend talks like this one. This is a good opportunity to network with each other, to meet people from different companies, usually when we have an event like this by Facebook, we have other recruiters or other people who might be interested in talking to the participants. They're like, hey, what are you doing? And they may take your resume if they think that you have a chance of passing the interview. Participating in hackathons or coding competitions. I know these guys at GDG, they're always organizing events for you, so make sure you come to those. They're usually a good way to not only improve your skills, but also network, and potentially you might get a referral or an interview from these events. Presenting at a conference or seminar, if there's a topic that you're passionate about, that you want to talk to other people about, it could also help you be seen and get you an interview eventually. Writing a blog, if there's something that you know about or you care about, you can talk about it in your blog. And sometimes recruiters, they go on the internet and they say, who are the people who are contributing to the documentation of a certain framework, or talking about solving problems. Like if there's now a new release of React, you see a lot of developers will write about it, like, oh, I used this React thing and I saw this problem with it and I fixed it this way, it's my solution to it. So having this kind of activity also helps you be noticed by other people in the community. And finally, submitting your resume online. This could be very simple and obvious. Of course, there are a lot of people who might submit their resumes online, so if you want to stand out, you want to be different, you probably need to do some of the other things I mentioned. Okay, then let's talk about the most interesting part of today's talk is how to do well in the interview. And this is what, this talk is saying, crush your coding interview. So this is how you crush your coding interview. So before we talk about how to do well in the interview, let's talk about why we do the interview. So the goals of it really is to see how you think and tackle hard problems. In just about every job you're doing, you're solving problems. And a lot of the times, these are relatively hard problems. If they weren't hard, then it would be anybody can do it, and you don't even need probably a person to do it. You could have a robot that does it. So we're always trying to solve hard problems in the job. And really, in the interview, we want to get a sense of your problem-solving skills. So we do this also by seeing how you look at engineering trade-offs. You're in a position to do engineering work. And when we think about engineering trade-offs, it's when we're saying, let's build a program that will be faster, but it saves us memory. Or let's make it use more memory because we need it to be faster. We don't have a lot of time. So these kind of trade-offs that we make when we design things. And all the time there are trade-offs in our choices. In our life, we make trade-offs. You decided to come to this workshop today instead of playing video games, maybe. So this is a trade-off. You said, hey, this is better to come here to play video games, or I don't know, watch the sunset or something. So we're always making trade-offs, and in the engineering trade-offs you make, you need to understand why you chose this or that, and you need to be able to explain it. So this comes up in the interview too, like, what is the speed of your solution or your program? What is the time it takes? What is the memory it requires? So also how you communicate about your coding. So we remember I said at the beginning, communication is very important. So this is coming up here. In the interview, you have to talk. You have to talk a lot. And communicating and talking about your solution is a big part of the interview. The limits of what you know. So in the interview, sometimes the interviewer will just ask you questions. They will keep asking you questions until you don't know the answer. And the reason they do this is because they want to get to the limits or the boundaries of your knowledge. Everybody has a limit to their knowledge. It's okay. So sometimes they may ask you questions you don't know the answers to, and that's okay. Don't feel bad. They're just trying to see, like, when do you stop knowing the answer to a certain situation or a certain problem? So don't feel bad when that happens. Any questions about this? No? Makes sense? Everything's clear? Okay, let's keep going. So what do we cover in the interview? I mean, I said the material is important. So a lot of times people, when they go to prepare for a coding interview, they go and buy a book of puzzles and they try to solve some puzzles. But we don't actually care about puzzles. Instead, we care about data structures and algorithms. So how many people took a course on data structures and algorithms? Okay, so that's about like 1/3 of the room, or even less potentially, and that's not good, because if you don't know data structures and algorithms, you will have a hard time in these kind of interviews, and you'll see in a second when we start solving some of these problems. So it's okay. Some of you may be students and maybe they haven't gone to that part yet. If you're first year or second year, maybe they teach this course in third year. But if you're not going to learn it in university, or you already finished university and you didn't learn data structures and algorithms, then I encourage you to go take a course online for it. There are hundreds of free courses on the internet that talk about data structures and algorithms. And you know, you can take a course that is like 3 weeks long, and you will probably learn a lot of useful things. And that's a really important. If you come to the interview not having an experience in data structures and algorithms, you are very unlikely to be able to pass it, because the majority of it talks about that. So let's talk about that in more details with data structures and algorithms. So thank you. So when we think about data structures and algorithms, it's important to understand, not memorize. So don't come to the interview having memorized 50 algorithms and think like, all right, I memorized 50 cool algorithms, they're so amazing, and now I'm going to be great, I'm going to pass it. That's not helpful. What you need to be able to do is understand how these algorithms work and understand how these data structures work. Now, I remember when I was a student, I used to always get confused between stacks and queues. Did people study stacks and queues? People know this? Yeah? How many people? Okay, not that many people, but here, let's talk about them quickly. So I used to always forget, what is a stack and what is a queue? And which one is first in, first out, and which one is last in, last out? LIFO and FIFO, I don't know if you guys have heard about this. It's just always confusing. And I still don't know which one is which, and every time it comes up, I have to work it out in my head. So I think, okay, a queue is like when you have a queue of people lining up at the grocery store to pay for their groceries. The first person who enters the queue is the first person who goes to pay the groceries. So it sounds like the first in is the first out. So that sounds like FIFO, first in, first out. And a stack is when you have a stack of books. You put your books on the table. The last book you put on the top of the stack is the first book you remove. So it sounds like the last in is the first out. So stack sounds like LIFO. So I have to do that every time I think about stacks and queues. And this is because I don't memorize which one is LIFO and which one is FIFO. I just understand how it works, and I can work it out in my head again. Same thing if you're going to learn binary search, or if you're going to learn merge sort, or quick sort, or heap sort, or any of these algorithms or data structures, try to understand them. Because what happens when you understand them, then you can use them, and you can play with them, you can change them, and you can use them to solve the problem that comes to you. Because most of the time in the interview, you're not going to get a problem that is telling you just write to me binary search or write to me merge sort. And we'll talk about this in a second. So, besides understanding, it's also important to discuss the complexity. Now, how many people know what this means? Complexity, big O notation, yeah? Okay, so now this is interesting because more people raised their hands when I said big O notation than when I said data structures and algorithms. And I don't know how you can learn big O notation without learning data structures and algorithms, but that's okay. So if you don't know big O notation, also, you should study that because it's another topic that will come up in the interview, and you will be asked to talk about what is the complexity of your code in big O, what is the space and the time complexity. And if you don't know what that means, basically it's asking you how much time is required to complete this algorithm, or how much memory is required to complete this algorithm or this program. And sometimes, if you need to use common library functions, it's okay. So if your solution is going to require you to sort the data in your, if you have an array of data and you need to sort it before you complete the solution, that's okay. Just invoke the library function that does sorting. You don't need to implement sorting. Or if you need to use a hash table, just use the hash table from the library of the language you're using. You don't need to implement hash table from scratch. Obviously, unless the problem is telling you to implement a hash table, but if you're just going to use hash table as an auxiliary tool for your solution, then just use what's available if the standard hash table is sufficient for you. Now, of course, it's important to understand, how does a hash table work behind the scene? What is the time required to look some things up, or to add things, to remove things from a hash table? Or what is the time required to sort the data when I just invoke the common library function for sorting? So understanding how it works or how much time it takes is important, but you don't need to re-implement it, write it from scratch in your solution. It's unlikely to be asked to implement basic algorithms. Like I said, we will not ask you to say, hey, implement binary search, and that's it, go home. That's too simple. And so we want to see, how can you use binary search to solve something else, or maybe modify binary search to work in another situation. Also, we don't ask specific questions about concepts. What this means is, we're not going to ask you, explain to me how memory management works in iOS version 12. Like, that's a very specific thing. You can Google it, and you only will know the answer to this if you're an experienced iOS developer. So we may ask these kind of questions if you claim to be an expert, or if you're applying to a position that requires you to be an expert on that specific domain. But most of the generalist positions that say, software engineer generalist, then we don't ask these kind of specific questions. And finally, use your most comfortable language. So this is a question I get a lot. People say, oh man, which language should I use for the interview? Or what's the best language to learn? And, that's, if I answer this question, I could get in trouble, because you say Python and people hate you. You say PHP and people get mad at you, and you say JavaScript is good and nobody will talk to you again. And so it's hard. Like, what is the best language in the world? There isn't one, right? So just use the one you're most comfortable with. If you like PHP, that's fine. Use PHP. If you know C#, use C#. The interviewer will be able to understand what you're saying and what you're writing, even if they don't know this language very well. Don't corner yourself into learning PHP the night before your interview because you heard, oh, Facebook used PHP, so now I have to solve the interview questions in PHP. And the reason for this, because we're asking these data structures and algorithms problems, they can be solved in any language. So just use the one you're comfortable with. That way you're not going to stumble on little things. Like, sometimes I interview people and they choose to write C++ code in the interview, but they don't put any semicolons. And it's like, okay, if you are writing C++ and you don't put any semicolons, then did you learn C++ last night? Because how could you be writing C++ code and not put semicolons at the end of your lines? Or I see people who come write Python code and they put semicolons. And it's like, okay, you obviously have not been writing Python code for very long. And it becomes confusing. Are you just inexperienced in Python, or are you inexperienced in coding altogether? You don't have a lot of experience writing code. So it confuses the interviewer when they see these little language-specific mistakes. So it's best to just pick your most comfortable language, the one you've been writing code in, and use that for the interview. Does this make sense? Yeah. Okay. Any questions about these things? I said a lot of things here. Yeah.
Can you share this PPTs, or we should take pictures?
I think there are some pictures or recordings being done. I can't share the slides, unfortunately, but feel free to take notes or photos of it if that helps you. All right. Other questions? Yeah.
We are asking about the complexity of your algorithm, and should you include this complexity of library functions that you use?
Yes.
Or you should not?
Definitely you should, because when you talk about the complexity of your algorithm, or your code, you're talking about the complexity of the entire thing, not just the parts you wrote, but the whole thing. So if your thing involves calling storage or search or something, hashing, then yes, you should include that in your computation.
I have a question.
Yes.
All we know that all the FAANG companies, including Facebook, have very hard interview process. Like, it's not easy to pass these interviews, and many people they say that the interviews is actually the hardest part of job in these companies, in big companies like Facebook, Google, etc. Is it Is it correct? Like, is the interview the hardest part? Because many people claim that when you get into such companies as Facebook, smart uncles, smart guys have already set up everything for you, and you just have to, just paint buttons, set some text. Yeah, is it correct or not?
Yeah, this is an interesting question. I think it's because it depends on how we measure difficulty, right? Like, there's a certain type of difficulty in algorithms and data structures, and there's also a certain type of difficulty involved in building websites and applications and scalable solutions. So it's true that we have an infrastructure that has made it a lot easier to develop on, but this infrastructure isn't meant to make the job boring or make it uninteresting. It's meant to make it such that you can focus on other problems. So the smart uncles who solve the infrastructure problems for us, it's not so that we just, work 1 hour a day and then go play ping pong the rest of the day. It's so that we focus on solving other problems, focusing on the users, focusing on the product. So we're not getting stuck making sure, is my application going to crash because there's not enough servers to serve it? The smart uncles take care of enough servers and enough traffic and those things. And there are people who have to do that. So, these people also have to go and interview, and they have to make sure they build infrastructure that is scalable for the other engineers to build their code on top of it. And everybody has a different kind of challenging problem to solve. The people who are building infrastructure have to make sure it's reliable and scalable. And the people who are building applications on top of the infrastructure, they have to make sure their applications are user-friendly, that they are intuitive, that they're solving the problem that they want to solve. So I say it's different kinds of problems. Some of them are more challenging on a technical, where you have to kind of like come up with a maybe potentially invent a solution. And sometimes you have to work more with using existing solutions that you have to package them and produce a product that works and solves the problem. Okay, this is a good question. So let's keep going, and we can pause again in a bit for questions. So we talked about what's covered. Now let's talk about the format of the interview and how does the structure play out. I have 2 more slides, and then we can start doing some problems together. So the first part of the interview is just an introduction, like 2 to 3 minutes long. You just say, hey, my name is this. The interviewer says, my name is this. You introduce yourself. It's a little bit like of an icebreaker opportunity to just settle in and just feel at ease and comfortable before you start the next part of the interview, which is the coding part. Now, the interview in general is about 45 minutes long. So the first part is 3 to 4 minutes or so. The rest of it, the coding, is going to be about 40 minutes, 35 to 40 minutes, where you'll spend the majority of the time completing a coding question. Sometimes the interviewer might stop you in the middle and just move on. That could happen because they might see, hey, this question is too easy for you. You're already solving it too fast. They can very clearly see like you can get to the solution without a problem. Remember, the interview, we want to see how you solve hard problems. So if the problem we gave you is too easy, we want to make it hard to see how you deal with it. So they may change it, or they may see that you're struggling, you're not making any progress, you're stuck, your brain is freezing. So maybe let's change the question, see if that's going to give you a better opportunity to demonstrate your skills. Sometimes there might be follow-up components or follow-up questions depending on how you solve it. So it could be that the interviewer will say, hey, let's make this solution faster, or let's make it use less memory, or let's make the code cleaner and less complex. So depending on the solution you implement, there might be some follow-up and iterations to be made. Be prepared to test your code. This is very important. Most people, or not most people, but a lot of people, they come to the interview, they write the code, they're very excited or nervous, they write the code, they finish writing, and as soon as they're done, right, I'm done. Give me the job. And that's not how it works, right? You know that as software developers, you always make mistakes. You always have bugs in your code. And that's why we have testing. We have manual testing, we have automated testing, we have all kinds of integration testing to make sure that our things do what they're supposed to do. And even then we have bugs and things crash, and that's part of the cycle of software development. So testing is integral. And if you skip it, you're skipping a very important part of the process. So most of the time when people test their code, they find there are some bugs in it and they fix it. And that's okay. If you have bugs in your code and you catch them and you fix them, that's a good thing. But if you just read the code and you stop and you forget about it, then that shows maybe you're not experienced enough, or you don't care about testing, or something is not good. So remember to test your code and treat it as a necessary step of the interview. If you're doing a phone screen, some phone interviews, you will use an online collaborative tool, and that'll just be you typing the code, but you can't execute the code. So when I say test your code, you will be testing it by hand, manually stepping through it line by line, as if you are the computer, and you're evaluating each line, you're manipulating the data. If a variable is being incremented, you increment it manually. If a for loop is going to break out, you break out of the for loop manually. So you will do the job of the computer. And this is because when you're on a whiteboard, you can't execute the code on the whiteboard. And the same thing, even if you're typing on a keyboard with an online tool for interviews, you still can't execute the code. And finally, there's some time for you to ask questions. So this is your opportunity to interview the company and the interviewer, learn a little bit about the job and the company some more before you take more steps with them. Okay, one more slide. This is maybe the most important slide in this workshop. Okay, so the steps to a successful interview. What do I need to do to succeed in the interview? And there's like 6 things to do. So you come to the interview, and the interviewer says, all right, I have this question for you. Write me an algorithm or a program or a function that does this and this and this and this. And you're very excited. You've been studying for months before this interview. You've done hundreds of problems. And you say, all right, yeah, I know how to do this. And then you start solving the problem, right? No, that's bad. You don't solve the problem right away. The first thing you do when you hear the question, you repeat the question back. You just say, okay, all right. So you want me to write an algorithm or a function or whatever that does this and this. And then they will say, yeah, I do. Or maybe they say, no, that's not what I said. And that happens a lot. You will not believe how many times I interview people who skip this step, and they just go on, they start solving the problem right away. And then 10, 15 minutes into the interview, we realize, wait a minute, this is not what I asked you to do. This is not what the problem is. And then now we just wasted a third of the interview doing something that is not what we wanted to talk about. So it's very important. This will take 30 seconds, but it could save you a lot of time. So just repeat the question. Make sure you're on the same page with your interview. Okay, so now you repeated the question. So now you can start coding, right? No, you don't start coding yet. Then you ask questions about the question. So making sure you understand any edge cases, if you have an array, what's in this array? Is it all numbers? Is it letters that I have to convert to numbers? Does it have any nulls, any empty values? Is it sorted? Is the array so big that it does not fit? Can I modify the array? Can I destroy it? Do I have to preserve the order of the elements? All these questions that you need in order to be able to produce a solution. If you're going to make assumptions, also state them. Make sure that assumptions that you're making are valid. Sometimes you may assume the array is sorted, and then you solve the problem assuming it's sorted, but it's actually not, and now you have to valid. Sometimes you may assume the array is sorted, and then you solve the problem assuming it's sorted, but it's actually not, and now you have to change your solution entirely. So make sure you state any of those major assumptions up front too. Okay, now, all right, you ask questions, you understand the problem, that's enough, right? You can start coding, right? It's a coding interview, so you should be coding, right? No, you don't start coding yet. Now you start thinking about what you're going to write. So this is also important. A lot of the time people, they have something in their head, and they just jump right to coding it. But then after 20 minutes of coding, they realize this actually does not work. This idea, this approach is not valid. they didn't try it with a sample input or with an example, and it just was like, this is never going to work. So it's very important to use some time to think and discuss and be like, okay, so I'm thinking of doing this, and I think if we just use a hash table, we'll put it in the queue, and then this, and then this, and I'm thinking we can use this thinking, and then you just talk about it. You can draw it on the board if you have it, or if you're doing a phone interview, you can draw it on your notepad. And once you feel confident that you have a solution that works, you understand all the parameters of it, and this is really the most important part of the interview, number 3. If you can formalize your solution in your head and you have a solution that is complete and coherent in your head, most of the time, turning it into code is the easy part. So this is when you start coding. Once you have the approach, you start writing code. And now when you're coding, you're just going to talk about the code. You're going to explain every line of code that you write. If you're going to write a for loop, if you're going to put an if statement, you explain it. You say, okay, this for loop is going to go over all the elements from the beginning to the middle of the array, or this if statement is checking if the 2 pointers are going to meet each other, or whatever. So you explain what each of these lines that you're writing is doing. If you get stuck, maybe don't use that too much though. Don't do too much into asking for hints, and to the point where you're basically asking the interviewer to solve the problem for you every step of the way. So use it very sparingly. And then after you write the code, you're gonna make some test cases. You're gonna run through it, and you're gonna see, how does it actually do? Does it do what I'm supposed to do? What it's supposed to do? Make sure when you pick the test cases, pick ones that could break your code. So if there's any potential for your for loop to go out of bounds, or for any potential for you to have a division by 0, or a null pointer exception, or whatever, any of these things, try to test those examples. Test it with an empty array, test it with an array that has negative numbers, if that's a valid scenario. Maybe the interviewer will say to you, you will never have negative numbers, so you don't have to worry about it. But if he says, yeah, there could be negative numbers, and that could be an edge case for your code, test it with that, see what happens. Test it with an array that has all zeros or all ones, depending on what you're doing. Maybe you're trying to deal with zeros and ones. So try to find those situations that could result in an edge case or a corner case for your code. And then finally, you iterate. So once you tested and validated that your code works, you might have fixed some bugs along the way. Then you say, okay, how can we make this better? And can we make it faster? Can we make it use less memory? Can we make it simpler? Maybe the code is a little crazy and too messy, so can we clean it up a little? Now remember, you're doing this in about 35 minutes. And sometimes the interviewer might actually ask you 2 questions in those 35 minutes. So you could have about 10, 15 minutes for the first question. Usually, if they ask 2 questions, they'll ask you 1 question at the beginning that's easy, just as a warm-up and as a way to get you comfortable. Which, if they're doing that, then the first question should be solved in about 10, 15 minutes. And then the second part of the interview will be for a slightly harder question. So you don't have a lot of time, as you can see. It's a very intense, very fast-paced process, and it's stressful, I will admit. And that's why practicing is very important. The only way you can master this and get comfortable with it and be at ease when you're doing this is if you do this tens or hundreds of times, practicing with each other, with your peers, with your cousins, and solving a lot of these interview problems. Now, you can get these interview problems on the internet. There's thousands of them. If you go on HackerRank, LeetCode, any of these websites, you'll find so many of these interview problems. And I encourage you to do at least 100 of these problems. I'm not exaggerating. Do 100 of them, or even more. But start with doing 100. Treat it like, if you're a student in university right now, which most of you are, treat this interview prep as a course. It's like if you have your operating systems and databases and whatever infrastructure, or I don't know what university courses are at. It's been 10 years since I was in university, but whatever your university course is, treat like you have another course that you made up for yourself called interview prep, and every day when you're having your breakfast, you solve a problem with breakfast, and then that way you'll take the habit of these interview problems. Okay, so I talked a lot. Now this is the last slide that has text on it. Now we will have code. So before we move on to do some coding problems together, any questions? A lot of questions. Yes.
What kind of cheaters have you encountered in the interview process?
What kind of what?
Cheaters.
Cheaters.
Yeah.
Oh, that's an interesting question. I've never had. So the question was, what kind of cheaters have I encountered in the interview process? And I haven't really experienced cheating. I think it's, a good interviewer will, if you don't memorize something or you're copying it, then like with the right questions, it'll show up. And I've never had anybody who was like copying, or at least I don't think. I mean, maybe they were so good I couldn't tell. But I've never had that problem. That's a very interesting question. Sounds like you're trying to think about. Okay. I've never had anybody ask me that question either. This is a good one.
Yeah. I'm a project manager, so that was interesting to see the software problem.
Okay. Yeah. I mean, the only thing that could be considered like an unfair advantage is if somebody had already seen the problem or like memorized a solution to it, and you can kind of see that very easily. When somebody's just like bam, 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 like they're not really thinking about the solution, they're just like reproducing it from memory. And I don't see that. Yeah, every person I've interviewed, they're working with me on the problem and solving it in real time. But we also try to look for those, and if we notice this, then that's when we change the questions. Like, all right, let's try something different. And then usually then the difference will be seen. It's like, okay, now there's a different problem and you can't really solve it, but the previous one you were just like this. So it shows you probably memorized the solution or you've already seen it. Okay, other questions? Yeah.
Do you interview yourself with questions from scratch, or do you take from some resources? If you take from resources, please tell us.
I shouldn't tell you. So the interview questions are actually considered internal, where we don't try to tell it, because like I said, it kind of defeats the purpose of the interview if we give you all the questions and you say, all right, I'm going to go memorize them, and then you come and you show your memorization. Because memorizing does not demonstrate problem-solving skills. It defeats problem-solving skills. So we want to avoid that. So, but the way you would solve this, or the way that you would prepare without knowing what the Facebook secret interview questions are, they're not really that secret. I mean, they're a variation of any of the lead code, HackerRank, or any of these things. Some of them might be identical. We try to avoid identical problems. Even if a problem we ask might appear on lead code, we try to make it a little bit different, just so that we see, adjust and navigate this difference. Even if you memorize the solution to the lead code problem, then are you able to make it work for the problem we're asking you? If you just blindly memorize, you can't make it work, because you memorize, you don't even understand what it's doing. But if you understand that solution, then you can come here to the interview and you can change it up and make it work. And that means you can solve problems. That's a good thing. So my answer to you is, like, we don't take it from one website. We have our own set of questions. And if you want to be prepared for those questions, just go and do 200 questions on lead code. You'll be fine.
What if I already solved some question and it, well, I'm not sure it's likely, but it appears on the interview. Should I tell the interview?
Yeah.
Because
They will usually tell you, if you've already seen this question, either in like yesterday you were practicing on lead code, or you saw it in an interview last week, just tell us, we'll change it. That's like that's what they ask you for, honest performance. Yes?
My question is about the differences in interview process for different interview positions. For instance, what is the how different are interviews for data science positions and software engineering positions?
Yeah.
Do you still have to go through a code interview, or is it like vastly different?
Yeah, very. It was asking about the difference between data science and software engineering interviews. Data science and data engineering interviews are different. In some parts of it, they are different. I don't actually know what they do. I'm not familiar with the data recruitment process. This is for software engineering. So what we're talking about here is for software. Yes.
My question is about first step in terms of writing the resume. Is it so important to having university degree for applying for Facebook or Google? For example, if I have no any university degree or master degree, what is it okay with me for applying for companies like Facebook, Google? What if I did some projects?
Yeah.
Projects, real experience, and
Yeah. So
experience.
yeah. So the question about is it important to have a university degree, and the basic answer to this is it depends. Some places. What's that?
Option is it?
It's I think in some cases it's not optional. For example, you have to get a job with Facebook in the US, and in order to come to the US, you need to actually have a university degree. Like this is what the government requires, not even what Facebook requires. So in this case, it's not optional. You have to have a. Now, I'm saying this at the same time, I have colleagues who don't have a college degree and they work at Facebook. So it's possible that sometimes you can get a job in a company without a college degree. My brother, he does not have a college degree, and he worked, and he's a senior engineer. He worked as a senior engineer in a few companies just by teaching himself things and getting experience through doing things. So it's possible. But like I said, there are some cases where the legal requirements or the certain position, it's not optional, the degree. So it depends on what you're looking at and what the company is, what their requirements are based on government and so on. Okay, let's take 2 more questions and then we'll keep going.
Can you give information about statistics? I mean, how many people try to pass into at Facebook, and how many people do it?
Yeah, that's a good question. I'm not sure. I don't know the statistics or the ratio.
From your career, I mean, 1 year.
Oh, from my, that's it. Yeah, I mean,
Career.
from my experience.
Yes.
Yeah, I think, I forget. I had a number. I think maybe, like from the people I interviewed, how many of them passed the interview? I can't remember. I think maybe it was 50 or 30% or something. So it does not represent the whole pool, right? Like, you know, when we look at how many people I interviewed, it's a very small number compared to the total number of people that apply. So I'm not sure. I'm forgetting what the number is. But yeah, I'm not sure how much it matters, because these are people that we're interviewing. They already get some kind of screening by the time they come to the interview. There's, you know, people who apply. There's millions of people that apply that probably they don't make it to the interview. Yes.
How interview versus time interviews?
Internship? Yes. Yeah. Very good question. So to clarify the difference between internship and full-time, when you apply for internship, you will probably just do 2 interviews of this kind, the coding interviews. Only 2, and they will be this kind of difficulty that I'm talking about. When you apply for full-time, you will do about 4 to 5 interviews, and then 2 of them will be coding, 1 of them will be more about past experience and projects, and 1 of them will be about system design. So we don't ask these kind of interviews for internships, the system design and past projects. And the coding interviews we do for full-time are the same that we do for internships. So we don't make them harder or easier. We keep them to similar level. Because we actually, you know, I said this, these things in the coding interview, the data structures and algorithms, they are more or less the fundamentals of computer science. So whether you're a senior engineer, or whether you're a new grad, or whether you're an intern who just finished 2nd year of coding, we want you to know these fundamentals and these basics, and we want you to demonstrate the problem-solving skills through these kind of problems. Okay, so let's keep going. We're going to do a couple problems together, and then we can take more questions from you guys. So now you will see this in action. We're going to actually make this in front of you, how to do these different steps. Okay, so this is an example where you come to the interview, and the interviewer says, all right, give me an array in which every number is between 1 and n. Determine if there are any duplicates. So, what do you do? What's the first thing you do? Yeah, so you repeat the question. That's good. So you say, all right, I'm just going to repeat this question to make sure I understand it, and you're asking me to write an algorithm or function that determines if an array has duplicates. And then the interviewer says, yes, that's correct. So we're on the same page for that first step. What do we do next? Yeah, so ask some questions about the problem. So what are some questions that you would ask? Hold on. Raise your hand and I'll yeah. Yeah, are they positive or negative numbers? So it's good. So we're saying 1 to n, so they're all positive in this case. Yes. Is the array already sorted? Yes, that's a very important question. Is it sorted? In this case, we'll say it's not sorted. Yes.
The limit of n.
Yeah, very good. How big is n? Because maybe the numbers are so huge, maybe I need to do something special for them. So does n actually fit in memory? Does it fit in the architecture or the integer size that I can have? So good question too. Yes.
What's the length of the array?
What's the what?
Length.
Yeah, what's the length of the array? So and maybe we don't care about the exact value of the length, but maybe we care like, is the array so big that it does not fit in memory? Like, do I need to break it up and fit it in the database or something? Good question. What else? Yes.
How much duplicates?
How many duplicates? Yeah, I mean maybe like what is the maximum number of So like what is the maximum number of duplicates that could exist in here? Yeah, so good question too. It's like, is it possible for a number to exist 3, 4, 5 times or only just twice? Is that the maximum it will be repeated twice? Other questions that you would ask? Yeah. What is the time complexity of the solution? Yeah, so in this case, a lot of the times, the interviewer will tell you, do your best. So they're not going to tell you what's the complexity you should use. They'll say, solve it with the best complexity you can come up with. But it's good to also ask. Yes? Does it include what? Yeah. Is it only integers or does it include floats? Yeah, that's a good question to ask too. What else? Got something? Yeah. He asked that question too over there. Yeah. So he said, how big is n? Is it going to be within 32 bits, 64 bits? Yes.
What accuracy?
What's what? Accuracy? Yeah. So in this case, we want 100% accuracy. So we want this to work all the time. So let's see some questions here I have. One of them is, can I destroy or modify the array? And you will see how this makes a difference in a little bit in the solution. So we will say, you're not allowed to modify or destroy the array. Treat the array as read-only. Can I use additional space? So another question. Again, most of the time the interviewer might say, use your best. Try to not use additional space if you can, but if you have to, that's okay. Will the array ever be empty? Maybe this question doesn't matter. Maybe the code will always work whether the array is empty or not, but sometimes you may need to ask this. And are they all integers? You guys ask this question, are they floats, integers? Maybe they're strings. I have to convert them to integers. So we need to also understand the data types of the array. So now we've asked some questions, we've understood it. We said we don't want to use additional space, and we want to keep the array as read-only. So we don't want to modify the array. So this is a very now constrained problem. We said the next thing we do is we just think about the solution before we write it. So what do you do in this case? How would you solve this problem? Yeah. It's not sorted.
It's not sorted when you quick sort.
But you can't sort it. We said you can't modify it. Yeah, it's read only. Yes.
You can store everything in the array, and if it's really one to n without any duplicate, and you to calculate the real sum and to calculate the sum as a input form.
Yeah, that's a good way to do this. This would work if the array, if the array has 3 numbers and all the numbers in the array are 1, 2, 3, and there are at maximum only 2 duplicates of anything, then there is going to be a certain type of sum that must exist, and that sum will be satisfied. So we don't actually know if there are duplicates only twice, because if there are 3 duplicates, like 1, 2, 3, the sum is 6. But if we had 2, 2, 2, then it would be 6 as well. So in this case, what's that? No, we cannot.
What do you get by additional space?
Additional space means if you create a new array, or if you create a hash table, or if you create a set. Yeah, that's the challenge.